I'm Daniel Huigens. I'm the crypto team lead at Proton, the developer of Proton Mail, Calendar, Drive, and VPN. And I'm gonna be talking about how to build a web app that doesn't trust the server. So what do I mean by that, or what do we want to achieve? So we want to build web apps that allow you to trust that we can't read your email in the case of Proton Mail, or your data in general, without trusting the server. So purely by looking at the clients, you can trust that your data is secure. So how do we do that? Well, we use end-to-end encryption. So in the case of mail, this means that when Bob, for example, sends a message to Alice, it means that Bob encrypts the message on his own device with the Proton Mail client, and then it's sent via our servers to Alice, and Alice decrypts the message on her own device, and at no point does our server have access to the message. So you don't have to trust the server is the aim. And clearly, open source is very important in this case. It's very important that the clients are open source so that everyone can check that end-to-end encryption is indeed actually being used, and that we don't just send the message in plain text to the server, for example. And the clients being open source makes it much more difficult for us to, let's say, maliciously send some code to the client that does that, or also if somehow our servers are compromised, it also means that we like if the source code were to be compromised and is sent to the clients, it would be easier to detect. However, it's not quite sufficient because nobody really reads the source code every time, and especially in the case of a web app, the HTML and the JavaScript and the source code of the web app is sent to the client every time that you open it. And it's very difficult to read everything every time, and might be still relatively easy to slip in some malicious code somewhere. And there are quite some points of failure where this might happen. Either an employee could be compromised, or the hosting could be compromised, or if we were to use a CDN that terminates HTTPS, then that could be another point of failure. Or if you're on a corporate network in a business, for example, that gives you TOS certificates to trust, then that could be another point of failure where the connection and thus the web app is compromised. And some of these things have actually happened in the past. For example, here's an example of Bootstrap JS CDN, which was compromised and served a malicious copy of the Bootstrap library, which had some malicious code appended to it, which would evaluate some malicious code. So it's not quite an idle threat, let's say. So what could we do about this? So one thing is you could think of is, well, maybe we should change the distribution model somehow. Like maybe it should be more like the mobile apps, for example, right? Where you have, the application is signed by the developer, but then it's also signed by the distributor, which could be, let's say, Google or Apple, signing the code as well. And then it's much more difficult to serve malicious code to one specific user, right? Because you're the distributor and the developer are not the same entity. So it's, let's say, less likely that they will be colluding. But this has many downsides, because it also means that you're beholden to this distributor. And well, one of the nice things of the open web is that anyone can develop a web app, and it would be nice to keep that. So what could we do better? So one idea is what I'll call source code transparency, by analogy to certificate transparency, which is an existing model that exists on the web today, where for every TLS certificate, it's published in an append-only log, and anyone can check that the certificates in this append-only log are the correct ones, and it basically makes it more difficult to maliciously create a TLS certificate and try to compromise a user. So we could do something similar with the source code, meaning, let's say we could hash the source code and publish it in a similar append-only log, or maybe even the same one, by requesting, for example, a certificate which contains the hash of the source code in the domain name. And that way, the hash would end up in this append-only log, and everybody could check that the hash of the source code that they actually got when they ran the web app corresponds to this published hash in the append-only log, and that it is indeed the version that was published. And this gives you that if any one person checks the source code, does read the source code to check, for example, that we are using end-to-end encryption, that improves the security for everyone. If any one security researcher would call us out saying, oh, there's some vulnerability in this version of the web app that you published, then other people also learn about it, which in turn disincentivizes us from publishing such malicious code, right? Or in the case where we're compromised, it makes it detectable. But in any case, it makes sure that everyone is running the same source code, and that should increase the confidence of everyone in that source code, ideally. But there's still an open question of how do we verify that hash once we publish it in this append-only log. So one option that we've looked at is to use a service worker for this. And a service worker is something that's installed in a web app, and it basically can cache a version of the web app, but also check when there's new code or a new version of the web app, check it somehow against some criteria. This is not really what a service worker is meant for. It's mostly meant for caching to improve the performance, but we could also use it for this purpose. So another option would be to build a web extension. That's also something that we've experimented with and are looking at doing. The only downside is, well, everybody would have to install this web extension to gain this protection. Although even if only part of the user base installs it, it still gives everyone some confidence in the published source code, as long as we can't detect in advance whether someone has this web extension installed. If we don't know, then it's, let's say, risky to serve some malicious code, because it could be detected by this web extension, which in turn should improve the confidence that everybody has that the source code is secure. And finally, and what I would say would be the ideal solution would be if this would be built into the browser. Of course, that yeah, would require some work on the part of the browsers, but some browsers have expressed interest in solving this issue. There are also real-world examples of applications that decided not to ship a web app because of this reason. For example, Signal decided not to build one until this issue has been solved. So hopefully we can eventually get a solution for this into the browsers. So finally, I should mention briefly some other options, other potential options to solve this issue. We've thought about publishing the web app on, for example, IPFS, which is a distributed file system that you can also publish web apps on. Although the tricky part is still how do you, when you deploy a new version, how do you make sure that it's actually the correct one? It's difficult. So IPFS normally just give you a link with a hash, or you can bind a name to hash, but it's still difficult to verify that it's the correct one. But that's another option that we're looking at. Or perhaps a Merkle tree-based name resolution or some kind of blockchain, perhaps publishing the hash to a blockchain. All of these things are things we're looking at, but we haven't decided on the final solution yet, but we hope to deploy something relatively soon. All right, thanks a lot for your attention, and that's all I have for today. Thank you.